A database that thinks it's a smart contract, and a smart contract that's just verifying a database. Stick with me for 4 minutes, because this is the architectural pattern that I believe you are going to see a lot more of. Most production systems, well, they're not going to go on chain, and maybe all of them shouldn't. Compliance screening, fraud checks, matching engines, eligibility on a tokenized fund, the routing layer on a payment stack. That work has to be fast, and a lot of it has to stay utterly private. But each of those systems has a control point, a moment where someone has to trust the right code did the right thing. A counterparty, a regulator, a customer. That boundary is what needs to be verifiable without forcing the rest of the stack on chain. Syndicate protocol open sourced a reference implementation of this pattern just a few months ago. They call it SyndDB. It's a SQLite replication system, and from the app developer seat, it is the SQLite DevX, the SQLite developer experience. The same libraries, the same connection object, the same SQL. Open a SQLite connection, call attach with a sequencer URL, start running SQL. The replication across nodes, the attestation that decides which nodes get to participate, all that lives below the line you are looking at. So where's the trust? Well, it's right here. When a new node wants to join, it has to prove it's running the right code in the right environment first. The bootstrap protocol is one enum. Generate a key, fetch an attestation from the trusted hardware the node is sitting inside, register that key on chain, verify the registration landed, ready, 8 name states, the whole loop, one screen. This is the function that closes that loop, written in Rust, compiled to WASM, running on Arbitrum via Stylus. It takes a Google confidential space attestation, parses the JWT, hashes the key material against an allowed list in the contract storage, verifies the RS-256 signature, and the SHA-256 precompiles. One transaction. Before this existed, the same check ran through a zkVM proving pipeline. 30 seconds at the fast end, 3 minutes at the slow end. 13 cents per proof on a self-hosted GPU. A whole service to deploy and monitor. Syndicate replaced that with what you're looking at right now. One Rust function, sub-second verification. 4 seconds down to 3. Look at where Stylus is sitting. Standard EVM would be so painful for this much crypto parsing. A generic off-chain prover was overkill for a check that finishes in milliseconds in trusted hardware. Stylus is the in-between layer Syndicate reached for, and it let them collapse the architecture by a whole service. This is the shape worth keeping. The hot path stays off-chain, fast, familiar, SQL native. The trust boundary, the question of who's authorized to participate, lives on-chain in one contract call. Compliance screening before a trade settles. NAV updates before assets move on a tokenized fund. Collateral checks before a position opens. Same shape, same kind of contract. If you're running production systems today, you've already got a few of these trust points sitting in your stack, with no clean way to make them verifiable yet. But that could change. If that pattern clicked, here is where to take it. Arbitrum is running a founder house at Open House London next month in July. A room of builders bringing real production ideas to the people building the platform for them. If you got a version of this shape in mind to bring to bear and to push to production, we want you in that room. Sign up today.